Hey guys, welcome back to the channel, and today in front of me I have the MAML 2022 test paper. And so it was a new paper from about March of this year, which I took in early March, and they're all proof problems. So the contest is 3 hours and they give you 7 long problems to do, and it's really interesting, and I wanted to show you the proofs of these problems. So the first one, it's pretty simple. It's a logarithm problem. So this one says, it gives you two variables, a and b, and it says let a greater than or equal to 1 and b greater than or equal to 1. So the first question is, show that log base a of b equals 1 over log base b of a. Now, a lot of times when you're confronted with such logarithm problems and they want you to prove something, the first thing that you should definitely do is take everything to the power of some exponent. So first thing, before I do that though, I'm going to simplify this a little bit. So I'm just going to say log base a of b times log base b of a equals 1. Well, presumably. We haven't proven it yet. But, yeah. So now what I'm going to do is, I'm going to take everything and take it to the power of AB. So I'm doing AB to the power of this left side and AB to the power of this right side. So that'll give us AB to the power of this stuff equals AB to the first, which is just AB. So if I separated this out, we would get A to the log base A of B times log base B of A times B time to the power of log base A of B times log base B of A. And so the thing that you have to notice here is we can simplify these. So A to the power of log base A of B, all of this is just B, and then B to the log base B of A, that is equal to A. So now we have B to the log base B of A times A, which is this stuff, to the log base A of B. And we know that B to the log base B of A is A, and A to the log base B of B is B. So that gives us equals A times B, which equals AB. And since we're trying to prove it equals AB, we have AB equals AB, which is our proof for A. So now I'm going to move on to the second part. So the second part is show that log base A of B squared equals 2 over log base B of A. So basically what we do here, it's very similar to the first one. So we take everything to the power of the exponent AB. So I'm going to simplify this a bit. So I'll move this multiplication over to the other side. So we get log base A of B squared times log base B of A equals 2. And again, I'm going to take everything AB to the left side equals AB to the right side. So AB to the log base A of B squared times log base B of A equals AB whole squared. So simplifying that gives us A to the log base A of B squared times log base B of A times B to all of this stuff, so log base A of B squared times log base B of A, presumably equals AB whole squared. So again, we do a little bit of cancellation stuff here. So we have A to the log base A of B squared, all of this is just B squared, and then to the power of log base B of A times, so B to the log base B of A, that's A. So we have A to the log base A of B squared. So now we know that this stuff So a to the log base a of b squared is just this stuff, so b squared, and b squared to the log base b of a. So I'm going to change this up a little bit. Since we have exponents, we can switch around the order of their products. So we can have b to the log base b of a all squared. So that equals, so b to the log base b of a is a, and a squared is just, well, a squared. So a squared times b squared equals a squared b squared, and ab whole squared is also equal to a squared b squared, which is what we were trying to prove. So lastly, for this third part, it actually has to do with a sum and not a product or a quotient or anything like that. So this last part is trying to tell us, so it's telling us show that log base a of b squared plus log base b of a is greater than or equal to 2 root 2. So while I was taking the test, a few of these things struck me about this question. So first off is asking about a sum, which is kind of weird for a proof problem, especially when talking about logarithms, which is something like you don't really want to find the sum of, and also it's an inequality. So that told me maybe we can use product sum inequality to tell us a little bit more about this problem. So if we use the AMGM inequality, which states that if you have two positive numbers, a and b, so ab greater than or equal to 0, this is kind of a little theorem. So a plus b over 2, the arithmetic mean, is always greater than or equal to the geometric mean. So if we use that here, so let's just say instead of a and b, I'm going to use like x and y. So let's just say x equals log base a of b squared, and y equals log base b of a. We have x plus y over 2 is greater than or equal to the square root of xy. So we know from the previous problem, so this looks very similar to the previous problem. If you forgot what it was, it said show that log base a of b squared equals 2 over log base b of a. Look familiar? Yeah, see, log base a of b squared, log base a of b squared, log base b of a, log base b of a. So when you multiply these two guys together, you get 2. So that tells us x times y equals 2. So now I'm going to replace this xy for 2 in here. So now you have x plus y is greater than or equal to 2 times root 2. So now we've just proven the original statement, right? Log base a of b squared plus log base b of a greater than or equal to 2 root 2. And that's the solution to the last one. So thanks guys, have a great day, and thanks for watching. Bye.